we are certainly going to do more of these. Says, what is the pH of sodium hydroxide in 25 milliliters of aqueous solution containing 0.0131 grams of sodium hydroxide? For this approach, what we're going to need to do is pH equals minus log of the concentration of H+. That's one of the equations we have. I would suggest we have another equation as well called the POH. That might be easier for us to use because we are working with sodium hydroxide solutions, which are basic. And the POH equation says POH equals the negative log of the hydroxide ion concentration, which is what we're going to have from this problem. And pH plus POH equals 14. So if we get the POH, we can use this equation to solve for pH. And I'm going to write 14.00. I know it doesn't change the math, but all pH values in this course have 2 decimal places. And even if when you enter the answer into the computer, it doesn't care, but you should get used to doing 2 decimal places for all pH values. All right, and I didn't mention this, but it's worth mentioning. Square brackets means concentration in molarity. So this really says the POH equals the negative logarithm of the concentration in molarity of the hydroxide ion. Okay. All right, so we need the concentration of hydroxide ion. We have grams of sodium hydroxide, and we have milliliters of solution. So the molarity of my sodium hydroxide solution, which we can get, is going to be my moles over my liters. I have my milliliters, so I can convert that into liters. So milliliters, move the decimal point 1, 2, 3 places to the left, and I get 2.500 liters. I have my grams, which I can convert into my moles, 0.0131 grams. And using the periodic table, so 22.99 for sodium, plus 16 for oxygen, plus 1.008. I get 39.998, which for me is going to be 40.00. Per 1 mole. Same old molar mass trick we've been doing for 6 weeks now. And let's figure this out. 0.0131 divided by 40. 0.000328. And that's going to be moles of sodium hydroxide. I don't really have enough space up here, but I'm going to do my best. 0.000328. And I can calculate that. Divided by 2.5. 0.000131. Now, so this is my concentration of sodium hydroxide. There's the sodium hydroxide breaks up 100% into sodium ions and hydroxide ions. So this is also the concentration of my hydroxide ion. Any questions about that? Okay. Because now if I have my concentration of hydroxide in molarity, I can plug that in to find my pOH, and then use this equation here to find pH. My pOH is going to equal negative log of my 0.000131. On my calculator, I have to enter it in first. Sometimes you have to hit the minus log button on some calculators, or the log button. I'm going to hit the log. I get 3.88 negative, but then I have a minus sign here, so I take away the minus sign here to get 3.88. And then pH plus pOH equals 14. My pOH is 3.88. Subtract to get my pH. And what you can do is, or what I do is, since it's negative right here, I can add 14, and I get 10.12 for my pH. Now, the pH has to be above 7 for this because it is a basic solution. And a basic solution means that you're talking about having more hydroxides than H pluses. So if I go all the way back down here, basic solution, pH greater than 7.00. And at least in my thought process, that makes sense because, I mean, I know I may have messed up something in these calculations, but I didn't mess up the part where my pH has to be higher than 7. Everything's good there. I guess, well, what I was going to say is one common mistake is to just plug the moles into the pH equation. And so make sure that you actually do moles divided by liters before you do the pH or the pOH equation in this case. Are there any questions about this? So many students in this class want to go into the medical area, and so understanding pH and pOH are an important part of that.